This is Unit 13, Nuclear Chemistry. Lesson 3, Nuclear Fusion and Fission. How are nuclear fusion and fission differentiated? The objectives of this lesson: I can differentiate between natural and artificial transmutation, I can distinguish between fusion and fission reactions, and I can compare the advantages and disadvantages of fusion and fission reactions. Do now. So, artificial transmutation is defined as a transmutation that occurs from bombarding a nucleus with high energy particles. The difference between artificial and natural transmutation are these two things. Artificial always has two reactants and it's considered non spontaneous. It doesn't happen by itself. Natural transmutation always has one reactant and it's spontaneous. It will happen by itself without the input of energy. So, nuclear reactions, if you add the actual masses of all the protons, neutrons, and electrons in an atom and compare it to the atom's actual mass, you can find that mass is lost. This is known as the mass deficit. Mass is actually converted to energy according to E equals mc squared. So the energy holds the subatomic particles together, and this is called the binding energy. So this is how our atoms don't always explode. There's always some amount of energy holding them together. However, when these reactions occur, nuclear reactions, small amounts of mass can be created into can be converted into large amounts of energy. So this energy can be harvested in fission and fusion reactions for everyday use. So this should say reactions. So fission reactions is when a neutron is shot at a radioactive source which splits that nuclear source and produces energy. So here is a neutron, and I'm going to throw it at uranium-235, and thus I'm going to create a larger unstable nucleus, which will decompose into barium and krypton, and will release three neutrons and energy. Lots and lots of energy. Lots and lots of energy. So if the number of neutrons released is not controlled, then a chain reaction will occur. So this is actually how we get nuclear bombs. When I take that uranium-235 and I bombard it with a neutron, these three extra neutrons, if they're not controlled, can hit other uranium-235s, which cascade in what we call a chain reaction. This energy is also produced in the above nuclear reaction. So here we don't see energy being produced, but that's where we get this giant explosion, that extra energy. So a chain reaction is defined as a series of reactions where each reaction is initiated by the energy produced in the previous reaction. Fission reactors work where the energy is released from the reaction is converted to steam, which turns a turbine system, creating electrical energy from nuclear energy. So here's a little picture of what a nuclear fission reactor looks like. Fission reactors have fuel rods that contain the fissionable radioactive source. This is our critical mass. We need to have a certain amount of our mass. The control rods, these things that go up and down, can regulate the neutrons absorbed, and this is what controls that chain reaction. In America, about 20% of electricity is generated by nuclear fission. This number might be a little bit different now, but imagine if we could power nuclear-powered cars. Imagine if we had a fuel cell that would be the size of a pencil. The energy would be equivalent to 1,000 20-gallon tanks of gas, and we could refuel every 1,000 weeks, which is about 20 years. So if we could harness this nuclear power into a car, it would be very energy efficient. Fusion reactions involve the combining or fusing of nuclei to produce heavier ones. So that's where I take two small nuclei and put them together to make a large one. This is what happens in the sun. So hydrogen atoms actually combine to form helium in a star. So how do we know the sun is made up of helium? Well, we look at the sun's bright line spectrum, and we can see that we get the pattern for helium. So here are some advantages and disadvantages. Advantages of fusion is it produces a ton of energy. The materials are really available. I mean, there's a lot of hydrogen around. There's not much waste, and there's no danger. There's no chain reactions. The problem is it's very expensive, and it's really difficult to contain a sun on the Earth's surface. So we haven't been able to create enough containment field, so to speak, to hold a sun on place. So to complete a nuclear equations for artificial transmutation, for example, complete this, we're going to do it the same way we've done before, where the mass of our top numbers, so 235 plus 1, so 236, has to equal the sums of these. and the sums of our charges have to equal each other. So what we'll find is we're missing 3 neutrons on the top, or 3 mass on the top, and nothing on the bottom, and that would be a neutron. So check your understanding. And now I can differentiate between natural and artificial transmutation. I can distinguish between fusion and fission reactions, and I can compare the advantages and disadvantages of fusion and fission reactions.